What's up everyone? For today's video, we will learn about algebra and compositions of functions. With that, let me ask you a question. How do functions interact with other functions? After we have defined functions in our previous episode, the next thing that we'll do is to understand how functions can be combined, added, subtracted, multiplied, divided, and even composited. Algebraically speaking, the same operations we apply to at least two numbers can also be applied in the case of functions. How? Let's look at this. As you know, we name functions arbitrarily using anything from alphabets, Greek letters, etc. You can choose with your own decisions what you should name for a specific function, provided that you can identify it like that for the entirety of the mathematical process. For instance, we let f of x and g of x to be the functions. Then, we can define their sum, or f of x plus g of x, as f plus g of x. Their difference, or f of x minus g of x, as f minus g of x. Their product, or f of x times g of x, as f times g of x. And their quotient, f of x over g of x, as f over g of x. Note that these are all just for the notations. Do you get that? Now let's have an example. If f of x is equal to 5x plus 1 and g of x is equals to 2 minus x squared, then what are the polynomial equivalents of the following functions? For f plus g of x, we just have to add. So, 5x plus 1 plus 2 minus x squared is equal to negative x squared plus 5x plus 3. Note that even though it is not wrong, but we must learn to arrange our polynomials from decreasing exponents for easier derivation. Next, for f minus g of x, we just have to subtract. So, 5x plus 1 minus the quantity 2 minus x squared is equal to 5x plus 1 minus 2 plus x squared is equal to x squared plus 5x minus 1. Commonly, students forgot to add parentheses when subtracting polynomials. But always remember that the negative outside represents negative 1. And so, by distributive property of multiplication, we have to distribute negative 1 to both terms of the binomial or a polynomial. Thus, if you encounter subtraction, always use parentheses. Then, for f times g of x, we have to multiply. So, quantity of 5x plus 1 times the quantity of 2 minus x squared, then, using FOIL method, 10x minus 5x cubed plus 2 minus x squared. Let's now arrange it to negative 5x cubed minus x squared plus 10x plus 2. Lastly, for f over g of x, we divide them. So, 5x plus 1 all over 2 minus x squared. Do we have a common factor for the numerator and denominator? If the answer is no, then let's leave it like that, but arrange. So, 5x plus 1 all over negative x squared plus 2. Now, what if we use the output of a function as the input of another function? Confused a little? Let's look at this. What do you think would happen if instead of x, we place g of x inside f of x? And that is the composite of functions that states that f of g of x is equal to f of g of x. Note that when it comes to compositions, the operations between f and g is unshaded, unlike in multiplication having a shade. How does the composition of functions work? Well, considering the functions earlier, their compositions would be f of g of x is equals to f of 2 minus x squared is equal to 5 times 2 minus x squared plus 1 is equal to 10 minus 5x squared plus 1 is equals to negative 5x squared plus 11. The compositions of the given factor yield to negative 5x squared plus 11. That's what we will use as the output of a function as the input of another function means. We use the polynomial equation to g of x and substitute them in all x's of f of x. Thus, negative 5x squared plus 11 comes. Now, it's your turn. Try to solve the following lessons or problems.